Welcome to the 9th in the series of videos on convex lens. In this video we're going to look at what happens when we move the object beyond 2f. Here you go, a simulation from simbucket.com, lens and mirrors. I urge you to play around with it. So let's take an arbitrary focal length, and when the object is at focal length you see that the image is formed at infinity. We move this object towards 2f. The image is formed, from infinity the image comes closer to 2f, and as we move the object to 2f, the image is formed at 2f. Now we move the object beyond 2f. So we see that as we do that, the object is, or the image is coming closer and closer to the focus. So let's see a demo, or actual demo on how the image formation happens for this use case. So here we have the lens at 60 centimeter mark and the candle at approximately 100 centimeter mark. So the object distance would be 100 minus 60, that's about 40 centimeters. So here we have the object which is at 40 centimeters, and we see a very clear image which is inverted but also diminished. It's much smaller than the actual size of the flame. It's approximately, let's say, about one-third, probably one-third the size of the original flame. And we can see the distance. So this is at 46.5 mark is a screen, and the lens is at 60 mark. So the difference between these two would be 60 minus 46.5, which is about 13.5 centimeters. Let's recreate the ray diagram for this, what we just now saw. So let's mark our f and 2f points with the lens. Once we do that, the object was somewhere pretty far away. Let's say this is our object. To draw a ray diagram, we take any arbitrary point of this object, and let's use scale to draw the diagram. So ray comes parallel to the principal axis, and that ray passes through the focus. So let's draw the line, that the ray that traces through the focus. And the ray that goes through the center of curvature, it passes through or goes undeviated. So let's also draw that. It's better to use a scale to draw these, because when you have to draw a line which is really long, it's difficult to draw by freehand if you don't use a scale. So here you go. So that's where the image is formed. Let's complete this ray diagram by putting in arrows. So that point is formed here. Let's complete the object by extrapolating. So this is your object and this is your image. We can straight away see that this image is inverted and real, of course, and diminished. In this particular case, the object distance was about 40 centimeters, and we found that the image distance was approximately 13.5 centimeters. So let's check if indeed this is 13.5 from our lens formulae. So the focal length of this lens is given as 10 centimeters. So let's apply the formulae. 1 by v minus 1 by u is 1 by f. 1 by v minus 1 by u is minus 40 centimeters because it's on the left of the optical center, equal to 1 by 10. In other words, 1 by v minus of minus is plus, and you take that to the other side, it gets a minus 1 by 40, that is equal to 30 by 400, or in other words, your V is equal to 40 by 3, which is nothing but 13.33 centimeters. So this is pretty much pretty close to what we found experimentally. So this is correct within 10% error, or rather even I would say 5% error, within 5% error. So this is okay. So the V is 13.33 centimeters. Now to find the magnification we know is V by U. That is equal to V is 40 by 3 by U is 40, so that's about minus 40, that's minus 1 by 3. What this implies is if your object is 5 centimeters, your image would be M times O, and that is minus 1 by 3 times 5 centimeters, that is minus 5 by 3 centimeters. So that's your size of your image. So I hope you enjoyed this video. We have visited all our learning goals: visual demo, ray diagram, applying lens formulae, and finding magnification for object greater than 2f. Please try to recreate your understanding in your notebook with your own narrative. If you get stuck, please watch this video again. See you in the next one. Bye.